Okay, so in this video, we're going to look at the Leisen Reimer 1996 model and consider how to implement some Python code for Leisen Reimer. Now, in this instance, there is no truncation, but the valuation that's performed is based on the complete guide to option pricing formulas by Espen Haug Binomial. So basically, if we go to this GitHub, we can see that some code was developed for Leisen Reimer, Python code for Leisen Reimer, and the code here basically follows the type of dynamic memory usage of Espen Haug's textbook. So it is, again, the complete guide to option pricing formulas by Espen Haug, 2007. And I've just basically taken that code here, right? So that's now, in addition, it might be noted that on this GitHub, there's Black-Scholes implied volatility. That's quite useful. And also Leisen Reimer implied volatility, right? Again, this can be quite useful. So something worth looking into, right? Okay, so just for basic implementation, very simply, we'll copy. Right. And again, if we consider the numbers here and the implementation, we can get output for the price of European American calls, European American puts, and we can also get the output for not just the price, but also the delta, the gamma, or all three. Okay, so the simplest way to implement is to use online GBD. I mean, it's handy because it's in the browser, but there's other options here as well. I kind of like this online compiler because we can just simply toggle between different programming languages. Okay, let's paste in. Right, now the formatting is a bit different because it's double-lined, but let's ignore that and just consider a few things. The numbers that we're going to use here, these numbers, the value of S, the value of X, the value of the maturity, the value of the risk-free rate. So go again, it's the values that we have here. I'll copy this again. So the values that we have here are consistent with the example we took from table 1 of the original Leisen Reimer paper. So we'll have S, X, T, R, B, V, N, and they're consistent with the parameters set out in table 1 of Leisen Reimer 1996. So I will delete this again. Just take out, and then I'll paste. Right, and again, the values that we have here are consistent with those of table 1 of the original Leisen Reimer paper. Now, if I run this, I'm not going to output the European call or the European put or the American put. In fact, I should probably, let's get the American put result. So we're going to get just the price of the American put for these arguments. And likewise down here, we'll just print the price of the American put option and the result obtained from here. So let's run that, right? And we get a figure of 7 points. So the price of the American put option with these arguments for S equal to 100, X 100, T equal to 0.5, R equal to 7, the cost of carry, B in Espen Haug's notation, C here, 0.7, meaning no dividend yield. Volatility is 0.3 and 25 steps. We're getting 7.2857. Let's compare that with the example 7.2858. So with rounding, same as the Excel. So this result looks similar. We could do a little test. Let's change this to 90. Right, let's run. And we get a value of 12.334142. Let's compare with the output from table 1. If the exercise is 90, we get a value, if the exercise, go back, what did I, okay, I should have changed the stock, not the stock price, but the exercise price. We change the exercise price to 110. Let's run. Right, 12.93 if the exercise is 110. Let's go back. Exercise 110, 12.93136. 1356. So it is, it's the same. Okay, so these values are consistent. If we want all the outputs, just remove the pound sign, and we have European call, European put, American call, American put, and they'll print out. Because there's no dividends, the American call and the American put, sorry, the American call and the European call will be the same. It won't be optimal to exercise early. So if the dividend is 0, the value of the American call and the European call is the same. However, it is optimal to exercise the American put. So there's quite a sizable difference opens up between those two. American European puts. Again, I have to be careful here. That should be 110, 100, so it won't be so, yeah. It's only a slight advantage, right? So for the American put, 7.028, for the European put, 6.69. Otherwise, a European call and American call are the same.